Okay, hello everyone. Today we will talk about the week 7, assignment 7, and for the course classical mechanics of a single particle. Okay, so let's begin. So today is 9th September, and we will basically focus on the previous year question answer with a detailed explanation, and then we will stop our class today. Okay, but before going there, I just want to mention one thing that in the previous class, I was sure maybe there was some internet issue or something like that. So what I saw that I could not finish the last two mathematics of that previous year questions, like previous week assignments. So right now, what I will do here, first of all, I will do here the last two mathematics what was there for the last week class. So this is the last week class question, like that a particle satisfies the differential equation d2x dt2 plus 2 dx dt plus 10x equals to 30 cos 2t with x0 equals to 0 and v0 equals to 0. Its position at time t is how much? So this is the question which was the last week question. So let me just write the equation first, and after that we will calculate. So what is that? d2x dt2 plus 2 dx dt plus 10x equals to 30 cos 2t. Okay, so d2x dt2 plus 2, okay, 2 dx dt plus how much? 10 equals to 30 cos 2t. Okay, so as you can see, this is the expression which is the second order differential non-homogeneous ordinary equation, differential equation. So for that case, our x will be two parts. One will be the complementary function and another will be particular integral, right? So x will be xcf plus xpi. So to calculate the xcf, what we will do, we will make this equation as a homogeneous differential equation. So this will be like simply this dx dt plus 10x equals to 0. So this will be my CF calculation expression, right? So if I want to tell the expression here, then what will be the answer? It will be m square. Let's say I am talking about x as a e to the power mt. Let's say. So it will be like m square plus 2m plus 10 equals to 0. So if I just calculate this one, then what will be the value? M will be like minus b plus minus root over b square minus 4 ac divided by 2a. So it is minus 1 plus minus root over 4 minus 40 divided by 2, which is, I can say, this is 36, that means 6, so that means 3i. Okay. Okay, so that means what? I can have the xcf as e to the power minus t, then let's say a cos 3t plus b sin 3t. Okay, so this is the xcf. My xcf is this one. Now coming for the xpi. So for xpi, we have to write that whole expression with the right hand side as well. So it is like this one, and how much was there? Plus 10x. Okay, equals to how much? 30 cos 2t, right? So this one was my the main expression, and I am going to write here the pi. To calculate the pi, what I will do, I will just simply write this x in a complex form. Let me write here as z. So it will be like z double dot plus 2z dot plus 10 z equals to 30 e to the power 2i t, right? because if I take the real part of all these things, then I can have the real part of this which is a cos of this. So I can write here the real part of this. Okay. Now for this case I will just simply write here a trial solution of z as, let's say, c e to the power I, actually it should be e to the power 2it. Why e to the power 2it? Because there it is e to the power 2it, so I will just simply take this value as this one. So if z equals to c to the power 2it, then our z dot will be c 2I e to the power 2it. Okay, and z double dot is c 2I square e to the power 2it. So it is nothing but minus 4c e to the power 2it. Okay. Okay. So now I can just simply write here 2z dot plus 10z equals to 30 e to the power 2it. If I just put all the values here, then it will become as minus 4c e to the power 2it plus 2 into 2I c e to the power 2it plus 10 c e to the power 2it equals to 30 e to the power 2it. So if I just calculate, cancel out e to the power 2it from both the equation as well as, so what it will left? It will left at minus 4 plus 4c, not 4c, 4I, plus 10 whole c is equals to 30. Okay. So it will be 6 plus 4I c equals to 30. So c I can calculate as 30 divided by 6 plus 4I. Now I can tell one thing, that 30, then 6 minus 4I, and then it is 36 plus 16. Okay. So the answer will be 36 minus 4I divided by 52. So the answer will be here 15 by 26, 6 minus 4I. Okay, this is the answer. But what is the answer? This is the answer for C. Now, if I want to write here the real of, let's say z double dot plus 2z dot plus how much was there? 10. 10z is equals to 30 to the power 2it, real of this. Okay. So it will be simply our z, what we took, it was e to the power 2it. So our x will be real of c e to the power 2it. Now what is c? C was 15 by 26, 6 minus 4i e to the power 2it. So this will give me real of 15 by 26, 6 minus 4i. Let's say it is like cos 2i, cos 2t plus I sin 2t, right? So if I multiply these things, then it will become as 15 by 26, 6 cos 2t plus 6i sin 2t minus 4i cos 2t minus plus 4 sin 2t. So if I am talking about a real part, then it will be simply 6 cos 2t plus 4 sin 2t. Okay. So my xpi is now 15 by 26, 6 cos 2t plus 4 sin 2t. Okay, I got xpi as well as xcf. So our x is xcf plus xpi. So xcf was e to the power minus the power minus t or 2t? T, I think. Yes, e to the power minus t. It should be that. A to the power minus t, a cos 3t plus b sin 3t plus 15 by 26, 6 cos 2t plus 4 sin 2t. So, now I will put the initial conditions. What are the conditions? At t equals to 0, x is 0, v is 0. So let me put here at t equals to 0, x equals to 0. So x is 0. So at t equals to 0 means this one will be 1. So then a. Then this one will be 0 plus 15 by 26. Here it is 6. Only 6. This is 0. So this is the thing. So now if I calculate here, this is 3, 13, 45 by 13. Now let me calculate the v. V will be x dot, which is e to the power minus, let me write here like in this way, ddt of e to the power minus t. Then a I got, which is minus 44, 45 by 13. What was there? Cos 3t plus b sin 3t plus 15 by 26, 6 cos 2t plus 4 sin 2t. So the thing is e to the power minus t minus 1 plus e to the power minus t, then cos the derivative is sin b 3 cos 3t minus 2 into 6 sin 2t plus 4 into 2 cos 2t. Okay, so at t equals to 0, v is 0, so it is, you can see here, minus 45 by 13 plus e to the power minus t, not e to the minus t, e to the minus t will keep 1, so it will be 3b, then plus 4 into 2 into 15 by 26. So it will be 45 by 13 plus 60 by 13 plus 3b equals to 0. So here we can see that it will be 105 by 13 equals to minus 3b. b will be 105 by or I think that will be, yes, cancel out. So 3, 3, 3, 5. So it will be simply minus 35 by 13. So if I put all the values here, a, b and all, so a I got this thing. What is this? A value? Yes. So a I got as minus 45 by 13. B I got minus 35 by 13. Okay. So it is 35, right? I think it's correct. You can see, you can just check this mathematics a little bit. 5, 10, right, fine. Plus 35 by 13. So the answer will be, I can write here, our x will be e to the power minus t. Our a is minus 45 by 13 cos 3t minus 35 by 13 sin 3t plus 15 by 26 6 cos 2t plus 4 sin 2t. Let me match here, minus 35 by 30. Okay, so that will be a 35 by 15, 13. Okay, then 15 by 6, 6 cos 2t, this one. Okay, so this one is the correct one. You can see all other expressions are wrong, so obviously this one is the correct one. Okay. So for this case, what we have done, we have taken the XCF and XPI, and then we calculated CF and PI explicitly, and we found that A and B and C are as this one, and after that, after putting all the value A, B, C, we will just calculate the expression for X. So our C was this one. Let me just box. Okay, maybe now I can go for next question. Yes, the position of a particle moving under the x-axis is determined by the equation this. That one was also given in that previous class PDF, but we could not finish that one due to the time constraint. Alright, yeah, so that's why I'm just writing here. If the particle starts with 0 velocity at x equals to 0, find x at later time t. So here also at t equals to 0, x equals to 0, v equals to 0. Okay. Now coming to here, d2x, dt2. There is nothing to say about here because this is exactly similar one the previous one. So I am just going to write this question equation, and then I will just write the solution 20 cos 2t. XCF. This is XCF. Okay, now XPI. So this is my XPI. So XCF plus XPI will give me A is given as -1. So if I just put these values, so 2b plus 2 plus 4 equals to 0, 2b equals to -6, b equals to -3. So our x will be XCF plus XPI, which is e to the power -2t minus cos 3t minus 3t or 2t, 2t minus 3 sin 2t plus how much was there? Cos 2t plus 2 sin 2t. Cos 2t plus 2 sin 2t. Okay, I'm going to write the full expression here as well. It is something e to the power -2t minus cos 2t minus 3 sin 2t plus cos 2t plus 2 sin 2t. Now you can just compare these expressions and I can see that this is the fifth one. Okay. So these two were the previous week questions. So now we will move for this week questions. Okay. So in this week, what sir was discussing? Sir was discussing about the initial frame of reference. Then there will be a non-inertial frame of reference. And if I want to match the non-inertial frame of reference physics, then I have to add some pseudo forces, and I have to take into account about some pseudo forces. This type of things sir was mentioning. So depending on these topics, there are some questions. Like first question can be written as like an initial frame of reference may be at rest with respect to an inertial frame, may be in acceleration with respect to a non-inertial frame, may be in uniform motion with respect to an inertial frame, should have same law of dynamics as that of inertial frame. So these are the some questions, these are the some options, and we have to take that which one is the correct one for inertial frame of reference. Okay. So first of all, I want to mention here for inertial frame of reference, actually this inertial frame of reference should be raised or with a constant motion with another inertial frame of reference. Okay. So what does this means? This means that maybe at rest with respect to an inertial frame, that is correct. Maybe in acceleration with respect to a non-inertial frame, no, that is not correct. Maybe in uniform motion with respect to an inertial frame, that is also correct. Should have the same law of dynamics as that of another inertial frame. Yes, that is also correct, because obviously there is the law of physics. Laws of physics should invariant under all frame of reference. Okay, so that is the thing. So obviously for this question, maybe at rest with respect to an inertial frame, maybe in uniform motion with respect to an inertial frame, and should have the same law of dynamics as that of another inertial frame. And for the inertial frame of reference, we will basically take care about the Galilean transformation. Transformation, and sir was explaining these things very well, so I'm not going to explain in detail what are these things. Okay, now coming to the second question, which of the following is or are pseudo forces? To have the knowledge about the pseudo forces, sir was explaining that we can have a expression, right? So these where sir was already explained these things very clearly in his lectures, but to have a good understanding, I just mention here that if I have a non-inertial frame and I am having that inertial frame, so the after doing some mathematics or something, then we can have that m d2r dt2 in non-inertial is equals to m d2r dt2 in inertial minus something, and these something are pseudo forces. So what are the forces here? These are like minus 2m okay, fine, omega cross v minus, like these are the simple rotational one, but even if there is no rotation as well, then also I can have these expressions. Okay, so what are these things? These are like I can tell omega cross V is there. Okay, then so this is known as Coriolis force. Okay, Coriolis force, pseudo force. One of the pseudo force is Coriolis force, and then another one is omega cross R. Then another will be one, actually omega cross R, that will be like that. Okay, and then there will be omega dot cross R. Okay, so this is Coriolis force. Okay, all the things will be M, and this is nothing but centrifugal force, and this is Euler force. So these three are pseudo forces in this case of inertial to non-inertial. Now which of the following are pseudo forces? Coriolis force, and the expression is minus 2m omega cross V. Just make sure that all the terms will be in vector notation only. Okay. Then the centrifugal force, that is also fine because omega cross R. Then Euler force, that is also fine, which is omega dot R. And gravitational force due to earth, obviously that is not the pseudo force because this is the mg, and you are all going to follow that one, you are all going to experience that one, so that will not be a pseudo force. Okay, so for this question, the Coriolis force, centrifugal force and Euler force are the pseudo forces. Okay, which of the following which statement is true about Galilean transformation? So first of all, Galilean transformation tells us that, let me write here, okay, so for the Galilean transformation we can have these things, that if I talk about xyz coordinate, okay, so this will be like x prime equals to x minus uxt, y prime equals to y minus uyt, z prime z minus uzt, and Sir was explaining all these things very well. So and also t equals to t prime in this case. Okay, so now coming to the question. In that question they were asking that it connects the spatial time coordinates of a particle seen by an inertial and a non-inertial frame. No. Why? Because for Galilean transformation applies only for inertial frame of reference. So this is not correct. It is consistent with the concept of absolute space and time. Yes, that is correct, because one of the main point in Galilean transformation is that okay, so that's why this one is correct. It is consistent with the fact that all inertial frames are equivalent. Yes, that is also fine. All inertial frames are equivalent. Why? Because for all inertial frame of reference the physics law remains invariant. Okay, and it is not valid for velocities close to the speed of light. Yes, that is also correct. It is not valid for the velocities close to the speed of light. Whenever we will talk about the velocity is very close to the speed of light, then we will talk about the special theory of relativity, which we are not going to talk here till now. So for this question, what are the correct answers? The correct answers are like, for the Galilean transformation, it is consistent with the concept of absolute space and time. It is consistent with the fact that all inertial frames are equivalent. It is not valid for velocities close to the speed of light. Okay. Now let me come to the next question. Yeah. 4. Question number 4. Coriolis force is a real force, is a no-work force, is a pseudo force, acts perpendicular to the direction of motion of a rotating frame. Okay. Yeah. So for this question, I just mentioned here what is the expression for Coriolis force, and after that we will talk. So for Coriolis force, the expression is minus m, let's say 2m, omega cross v. Okay, very good. So, and okay, this is obviously a pseudo force. Now, according to the first question, this is first option. This is a real force, that is wrong, and this is a pseudo force, that is correct. Now, no work force is correct or not? Okay. So, the Coriolis force is perpendicular to the velocity of the particle in the non-inertial frame of reference, right? Now, work is what? Work is force and displacement, right? Now, displacement is along with velocity, okay? So, work will be force, like work will be proportional to force into velocity vector. So if I do that one, then obviously you can see our omega cross v and our force is perpendicular to velocity vector. So this will give me a 0 answer. Okay. So Coriolis force implies no work on the particle. Okay. So this will be right. Acts perpendicular to the direction of motion in a rotating frame. No, direction of not motion. Acts perpendicular to the velocity of the particle in a rotating frame of reference. So this is not correct. Okay. Okay. So now coming to the next question. Okay, so what is the question here? The question is for a vector v equals to omega cross a, where omega is a constant angular velocity, the total time derivative in the inertial frame is, so this will be as b equals to omega cross a, so simply I can write dB dt inertial equals to dB dt rotational plus omega cross b. So dB dt rotational plus omega cross a. Okay, so now you can see actually they should have told that in which frame of reference they are talking about b. So if I will talk about that b is in a inertial frame and b prime, let's say dB dt rotational plus omega cross a will be correct. So for this case this one will be the correct option, but here the question is not complete, so that's why we can't talk any more about this options here. Okay, but I have seen in this like obviously I am not going to tell the details about this year this year assignment week 7, but I have seen there is a similar question with a proper definition as well as proper information. So by seeing these informations we can see the actual option there, but here in that case of question number 5 we can't have a proper information, that it is only saying that b is a vector and which is in the inertial frame is how much. Okay, so inertial frame is how much means they are not talking about the rotational frame, how the b is going to behave. So it's simply dB dt inertial equals to dB dt rotational plus omega cross b I can say from the very safe condition. So omega cross b means omega cross a will be there. So that's why in that sense the equation number the option number 3 is correct. But obviously in this year question in this year week number 7 assignment I can share complete like information they have given according to what they are going to ask. So according to that one, that is exactly correct, no problem. Okay, now coming to the 6th question. A particle has position r is this one in a rotating frame. Find the Coriolis force at equals to 2 for unit mass and omega is this one. So let me first write all the given data. RT is 40 square plus 1 I cap minus 60 plus 40 square. Okay, what are given? T equals to 2, m equals to 1 and omega is I cap plus j cap plus k cap. So they are asking first Coriolis force. Okay, this will be simply minus 2m omega cross v. Okay, so but here I can see they are given that r and omega and m is also given. So how we can calculate the v? V will be simply dr dt. And okay, let me, yes. So a particle has position this in a rotating frame and the Coriolis force in the rotating frame they are talking. So I am just writing here simply dv dt, dr dt, and ddt of t square plus 1 I cap minus 6t j cap plus 4t square k cap. And what will be the answer? This will be 2t I cap minus 6 j cap plus 8t k cap. Okay, so this is my V. Now coming here as Coriolis force. So this will be minus 2m omega cross V. Now I have all the documents with me. So m is 1. Now first I will calculate this one. I cap, j cap, k cap, and omega is 1, 1, 1. And V is how much? V is 2t minus 6 plus 8t. So this will be 8t plus 6 plus j cap, 2t minus 8t plus k cap minus 6 minus 2t. So this is 8t plus 6 I cap minus 6t j cap minus 6 plus 2t k cap. Okay, and they have already given that t equals to 2. Okay, so minus 2 into all these things at t equals to 2. So at t equals to 2, 8t plus 6 minus 6t minus 6 plus 2t, this. Oh, that should be sorry. That should be minus. Yes. So if I put the value of t here, 16 plus 6 I cap minus 12 j cap, 6 plus 4 k cap. So it will be 22 I cap it is 12 minus 10 k cap. So finally I will have 44 I cap plus 24 j cap plus 20 k cap. So let me check. Okay, minus 44 I cap plus 24 j cap plus 20 k cap. So that means this one is the correct option. First one. Okay. So this is the Coriolis force at t equals to 2 for unit mass and omega equals to I cap plus j cap plus k cap. So for that what we have done, we just wrote here the t expression. Our expression t square plus 1 I cap minus 6t j cap plus 4t square k cap, and we put here m equals to omega, m equals to 1, omega is I cap plus j cap plus k cap. Coriolis force we know minus 2m omega cross v. V we have calculated dr dt. It is 2t I cap minus 6 j cap plus 8t k cap. Then the Coriolis force will be minus 2m omega cross v. Then simply we will calculate omega cross v, and we are getting the answer as 8t plus 6 I cap minus 6t j cap minus 6 plus 2t k cap. So if I put the value of t as 2 and m equals to 1, so Coriolis force will come as minus 44 I cap plus 24 j cap plus 20 k cap. Okay. Now coming here that what will be the Euler force on the same particle at t equals to 1. Okay, so yeah, so same particle means whatever the equation given, like this one was given as well as this one was given. So this is this m equals to 1 is given, and RT is t square plus 1 I cap. Then let me see what was the value of R cap. R cap. Oh. Minus 6t j cap plus 4t square k cap. So these were the cases. So Euler force. Yeah. So for Euler force, what we need to calculate here, we just need to do dr dt. I can write here. This is this one, and one minus sign is there, and one m is also there. So you can understand here at the very first we will calculate this ddt of. But surprisingly, we can see that omega is not a function of t. So that means if I do the ddt of I cap plus j cap plus k cap, it will simply give me a 0 value. So the Euler force for this case is 0. Right? Yeah. So this one is the answer. Obviously, we don't need to calculate at which t we are talking about. T equals to 1, t equals to 2 every time. The answer will be 0 only. Because our omega is not a function of time. Okay. Yeah, now coming here. What is the centrifugal force acting on the same particle at t equals to part 5? Okay. So same particle means, first of all I just want to write here whatever the information given. So this one plus 1 plus 60 square k cap. Okay. So here what they are asking? They are asking centrifugal force. So centrifugal force. And another one is given this one is given. So these three terms are given. Now centrifugal force, that will be simply omega cross r. Okay. So for that case, what we need to calculate first we are going to calculate omega cross r. Sorry, it will be t square plus 1 only. T square plus 1 minus 60 4t square. Now you can see t square plus 60, then t square plus 1 minus 4t square plus k cap minus 60 minus t square minus 1. So I can write here 4t square plus 60 j cap minus 3t square plus 1 minus t square minus 60 minus 1. Okay. Now this whole will be omega cross this. So that means this. So for that I cap, j cap, k cap, 1, 1, 1, 4 t square plus 6t minus 3 t square plus 1 minus t square minus 6t minus 1. So now let me calculate. So this will be so this is okay, so this will be simply you can see minus t square minus 6t minus 1, then minus plus 3t square minus 1 plus j cap 4t square plus 6t minus plus t square plus 6t plus 1 plus k cap minus 3t square plus 1 minus 4t square minus 6t. Okay, so this is the case. So if I simplify a little bit here, then it will come as 2t square minus 6t minus 2 plus j cap 5t square plus 12t plus 1 plus k cap minus 7t square minus 6t plus 1. So now this is the omega cross r, and m is 1 obviously, so we don't need to worry about this one. The centrifugal force acting on the same particle at t equals to 1.5. Okay, so now t equals to 1.5. Is this one. So t equals to 1.5. So okay, you can see here the answer will be simply 4.5 minus 9 minus 2, 10.75 plus 18 plus 1 minus 15.75 minus 9 plus 1. So after simplifying, this will be minus 6.5 plus 29.75 minus 23.75. So let me see the answer. Yes, this one. So the centrifugal force is m omega plus r. Okay, and this is the minus 6.5 I get plus 29.75 JK minus 23.75 KK. Okay, now coming for the next question, to find the velocity in the inertial frame at t equals to 2. This is a good thing. Like, okay, first of all, velocity. Velocity is dr dt, we all know, but we have r in rotational frame, which is t square plus 1 I cap minus 6t j cap. How much was there? Plus 4t square k cap. So this is in rotational frame. Now we need V in inertial frame. So for that case, our V inertial will be V rotational plus omega cross R, and omega is given as this, R is given as this. So first we are going to write this. So this is simply ddt of r vector as rotational. So this will give me 2t I cap minus 6j cap plus 8t k cap. Okay. Now omega cross r I need to calculate. One t square plus 1 minus 6t 4t square. T square plus 60 t square plus 1 minus 4t square minus 60 minus t square minus 1. So this will be 4t square plus 60 minus 3t square plus 1 minus 60 minus t square minus 1. Now at t equals to 2, okay, so at t equals to 2, omega cross r is 16 plus 12 minus 12 plus 1 minus 12 minus 4 minus 1. (28) minus 11 minus 17. So V inertia, V rotational, this. And what is V rotational? V rotational is 2t minus 6 plus 8t. 2t minus 6 plus 8t. At t equals to 2. So this will be 4 so this will be simply 32 17 minus k cap. So I can see 32 minus 17 minus k cap. This one. As they are talking about the inertial frame velocity, so we have to use this one. dr dt rotational omega cross r. Okay. Yeah. So this is the question. Question number 10. For a particle moving near the Earth's surface at 60° latitude, Taking the Earth's rotation into account, the equation of motion in a rotating frame, assuming diurnal motion only, is. So here, for this case, sir was already discussing about the equation of motion, and I'm just going to write this expression because it's already derived by sir very clearly. So I'm going to write the expression only here. This is this one. Let me write a little bit further. Y double dot is minus 2 omega cos lambda x dot omega sin lambda z dot z double dot is 2y dot sin lambda omega minus g. Okay, so these are the equation of motion. Now in this question, lambda is given as 60 degree, and they are asking that what will be the value of y dot, y double dot. Okay, so if lambda is 60 degree, then x double dot will be 2 into omega cos 60 y dot, and cos 60 is half, so it is omega y dot. Then y double dot is minus 2 omega cos 60 x dot plus omega sin 60 z dot. So this will give me minus 2 omega 1 by 2 x dot plus omega root 3 by 2 z dot. So this will give me minus 2 minus omega x dot plus root 3 omega z dot. Okay, and what about z dot double dot? Z double dot will give me 2y dot sin 60 degree omega minus g. So this is root 3 y dot omega minus g. Okay, now the omega value is nearly 7.29 or 7.27 sometimes they are calling, into 10 to the power minus 5 second inverse. So if it is like that, then I can write here x double dot is 7.29 into 10 to the power minus 5 y dot. Y double dot can be written as minus 7.29 10 to the power minus 5 x dot plus root 3 z dot. Z double dot is root 3 into 7.29 into 10 to the power minus 5, then this is y dot minus g. Okay, now let me come to the question. The question told that, okay, so they are asking about the y double dot. So y double dot is already here, we have already calculated, and this is minus, I can write it like, okay, I think I have written here properly, minus 7.29 into 10 to the minus 5 x dot plus root 3 z dot. So this is x dot plus root 3 z dot, that is this first option. Okay, so the first option is correct one. This one not, this one not, this one. Okay. So now coming to the next question. For a particle moving near the Earth's surface at 30-degree latitude, taking the Earth's rotation into account, the equation of motion in a rotating frame, assuming diurnal motion only, is, it is exactly similar as the previous one. So, but we will just replace that lambda value from 60 degree to 30 degree. So again I can write here I can write directly 30 degree. Cos 30 degree H dot double dot is 2 y dot sine 30 degree omega minus c. So if I do these things, then x double dot will be 2 omega root 3 by 2 y dot root 3 omega y dot root 3 7.29 into 10 to the power minus 5 y dot. Now y double dot is minus 2 omega root 3 by 2 h dot plus omega half z dot. So this is minus 7.29 into 10 to the power minus 5 root 3 h dot plus z dot. And coming for the z double dot, it is 2 y dot sin theta is half omega minus z. So it is 7.29 into 10 to the power minus 5 y dot minus g. So they are asking about y double dot. That means yes, this is y double dot. Minus 7.29 into 10 to the minus 5 root 3 h dot plus z dot. Root 3 h dot plus z dot. That means the second one. Root 3 h dot plus z dot. Yeah. Okay. So now this one. This one is again coming for the inertial frame of reference. So here inertial frame of reference will be like an inertial frame of reference may be at a rest with respect to an inertial frame. Yes, that we have already explained in the first half of the lecture. Maybe in acceleration with respect to an inertial frame. No, it is not correct. Maybe in uniform motion with respect to an inertial frame. Yes, that is correct. Should have the same law of dynamics as that of an inertial frame. That is also correct. May have some non-zero net external force acting on it. Yeah, that can also be fine. Non-zero net external force. Shell frame. So there is nothing to explain about this inertial frame. Now we can come to the next question. Which of the following is or are pseudo forces, Coriolis force, Euler force, and what of the particle in the Earth's gravitational field? So this is exactly similar that Coriolis force is the pseudo force, then Euler force is also the pseudo force, but this is not the pseudo force. So the A option and B option are correct one. So basically for the rotation of a in the rotating frame of reference, the pseudo forces are Coriolis force, centrifugal force, Euler force. So these are the forces which are pseudo forces in the rotating frame of reference. And obviously the earth gravitational field, it is a real force, so we are not going to talk about this as a pseudo force. Okay. Okay, so which is or are true about Gaussian transformation? It connects the space and time coordinates of a particle seen by an inertial and non-inertial frame of reference. No, this is not correct, because we have already discussed that one, that Gaussian transformation is only applicable for the inertial frame of reference, and it is consistent with the concept of the absolute space of space and time. Yes, it is true. It is consistent with the fact that all inertial frames are equivalent. Yes, that is also correct. It is not valid for velocities which are close to the speed of light. Yes, that is correct. It is considered the fact that Newton's laws are true for any inertial frame of reference. Yes, that is also correct, because basically this one and this one are similar. That it is considered with the fact that all inertial frames are equivalent, and it is considered with the fact that Newton's laws are true for any inertial frame of reference. Okay. So for this case, I can have that B, C, D, E. These four are correct. Like if I put here A, B, C, D and E option. Okay. So now come to the next one. Yeah. Correlative force is a no work force. Pseudo force comes into play only when the particle has a non-zero velocity in the inertial frame, act in a direction perpendicular to the direction of rotation of the rotating frame of reference, may cause a deflection in the wind direction of earth. Okay. So this is a no work force that we have already calculated, because the force into displacement is there, and displacement is proportional to, let's say, velocity. The direction is velocity direction, and so velocity and force are parallel to each other, so that means the work will be 0 here. I mean, like perpendicular to each other, so it will be 0. Okay. So and it is a pseudo force. Yes, correlative force is a pseudo force, and now it comes into play when the particle has a non-zero velocity in the inertial frame. No, when the particle has the non-zero velocity in the rotating frame, then only we will have the correlative force. Maybe I can write here. Comes into play. Force comes into play when the particle has a non-zero velocity in the rotating frame of reference. Okay, so this is not correct, whatever it is given here. Acts in a direction perpendicular to the direction of rotation of the rotating frame of reference. No, that is also not correct, because it is always acts in a direction perpendicular to the velocity vector of that particle. Okay, not the direction of the rotation. May cause a deflection in the wind's direction on earth. Yes, that is correct, because like Fresnel's law is coming here into that picture, that in the presence of a correlative force, the wind will deflect. Okay, so yeah, so the first thing I just want to here mention about that correlative force. We were talking some correlative force questions in this question as well. Where is that? Yeah, this direction of the rotating frame, obviously it is not correct. It is to the direction of the particle. Okay, vector there was a question about Coriolis force. I think there is no question about okay, fine. Now it is fine. So this is like I can see some here the Coriolis force expression. No. Okay, great. Let me just verify a little bit more. No, yeah, fine. So the Coriolis force is a no-work force, it is a pseudo force, and obviously comes into play when the particle has a non-zero velocity in the rotating frame of reference, and the rotating Coriolis force acts on in a direction perpendicular to the direction of the velocity vector of that particle, not the direction of the rotation of the rotating frame of rotation, and it may cause a deflection in the wind direction on the earth. Yes, that is correct. So for this case, the first one, second one, and the fifth one is the correct option. Okay. Okay. So maybe we will recapitulate all these questions a little bit. Yeah. So this one was the last question. They are asking about the Coriolis force. What is the nature of that? Then the previous one was about the Gaussian transformation, and which one will be the correct one. We can see that B, C, D and E are the correct one. Now question number 13 is that what are the pseudo forces are there, and which is like here the Coriolis force and Euler force are the pseudo forces. Now about the initial frame of reference, the first one is correct, third one correct, fourth one is correct, and fifth one correct. Yes, about the y double dot equation of motion calculation, we can get the equation answer as 2, and like when the lambda equals to 30 degree, and what will be the earth's rotation, the equation of motion along the y direction. So it is coming as y double dot equals to minus 7.29 × 10 by minus 5 root 3 x dot plus z dot. Similar question is here with the lambda equals to 60 degree, and it is coming at x dot plus root 3 z dot. And this is the velocity in the initial frame at t equals to 2 with the first question. I mean, there is a long list of questions, like they have given the r and omega and m equals to 1, and at different time they are asking about different parameters, like the velocity in the initial frame, then they are asking about the centrifugal force, then they are asking about the Euler force, and then Coriolis force. So centrifugal force is this one. So basically for velocity in the initial frame, we need to talk about that. The velocity in the initial frame equals to velocity in the rotational frame plus omega cross r. So that should be there. Then Euler force. Then in the same question they are asking about the Coriolis force. Then there is another question that B is given, and what will be the total time derivative in the initial frame, and there will be omega cross B will be there, and omega cross B is omega cross A, so that means omega cross A will be there. And this one is there, that what is Coriolis force, which is no work force, pseudo force, and acts perpendicular to the direction of motion. Not direction of motion, it is acts perpendicular to the perpendicular of the velocity vector of the particle. Then which statement is true about the Gaussian transformation? Here we can see that it is consistent with the concept of absolute space and time. It is consistent with the fact that all inertial frames are equivalent. It is not valid for velocities close to the speed of light. Otherwise, it will come as special theory of relativity. Which are the following pseudo forces: Coriolis force, centrifugal force, and Euler force. Now, this question is: inertial frame of reference may be at rest with respect to an inertial frame, may be in uniform motion with respect to an inertial frame, and should have the same law of dynamics as that of another inertial frame. Then we were talking about the last 2 week last two questions. Like this one is the position of a particle moving in x-axis is determined by the equation. If the particle starts with a zero velocity at x equals to 0, find x at latter time t, and we are having that 5, option number 5. And the first question is this one. Yes, particle starts satisfies the differential equation. And what will be the answer for this? It is coming as option number 1. Okay, so this is about all the this week questions and answers with the detailed analysis. So for the convenient one, I am just going to go through once again.